Welcome to qnawire.
Okay, so first we need to discuss what the Hammond postulate is. Recall that if we have a reaction and there's some transition state, let me draw the transition state first. Okay, let's say this is our reaction, right? So there is our reactants and our products and our transition state, which I'll just call a double dagger, right? If our transition state is closer in energy, which is delta G double dagger, to the reactants, then our transition state looks more like the reactants. If our transition state, the change in energy between the transition state and the product, is smaller, then our transition state looks more like the product. So in this particular instance, we would have a transition state that looks like the reactants. But if instead we had, for example, we could do the following. Right? Where this delta G double dagger is much larger than this delta G double dagger. In this case, we would have a product favored transition state. Our transition state would look more like the product. Okay, so now let's go through these. In exothermic reactions, the transition state is closer in energy to the reactants. Okay, so that's saying exothermic. I guess here we're talking about delta H. We're not talking about delta G, but that's fine. And they're saying in exothermic reactants, the transition state is closer in energy to the reactants. So if it's exothermic, that means that the final energy is lower, right? So no matter where we put this transition state, it's going to be closer to the reactants. That is true. Okay. And I think, let's see, let's skip to number 3. In endothermic reactions, the transition state is closer in energy to the products. So, right, endothermic means that the final product is going to be higher in energy. And this is also true, right? That in endothermic reactions, the transition state is closer to the product in terms of energy difference. Okay. The Hammond postulate provides a quantitative estimate of the energy of the transition state, and that is false. There's nothing quantitative about this. It's purely qualitative, right? And that's the difference, right? So we haven't invoked any numbers or anything like that. We're just comparing distances, larger, smaller, larger, smaller, transition state being more like or less like, right? Quantitative implies that we would have numbers to ascribe to this, and we could say 3 kilocalories per mole or 5 kilocalories per mole exactly. But that's not what we're doing. This is purely quantitative. So in actual fact, that second statement provides a quantitative estimate is not true. And then the final statement, it's the same, but with qualitative, that is true. So the second option is not true.